So we're going to take a look at the very last two exponent rules that we're doing. So what I want you to do is take out your chart where we've been keeping track of all the exponent rules, and we're just going to fill in from here. So the first rule that we're going to look at is the quotient of powers rule. So what does that mean? We're going to look at dividing two different powers. The rule is b to the m divided by b to the n is equal to b to the m minus n. So a couple examples might be 2 to the 8th over 2 to the 5th. Right, we just subtract those exponents. So we get 2 to the 3rd, which we can do a little bit easier. Right? So 2 to the 3rd is 2 times 2 times 2, which is 8. If we look at something with an exponent, x to the 15th divided by x to the 7th, simply x to the 15 minus 7, x to the 8th. So why does this work? Well, if we take a look at something like this, right? 2 to the 8th is simply 2 multiplied by itself 8 times, and 2 to the 5th is 2 multiplied by itself 5 times. Oh, I'm talking but not listening to myself. 5 times. So you can start to cross out things on the bottom, right? So division means that 2 divided by 2 is 1. So that makes a 1. 2 divided by 2, right? So these all sort of cross out. So there's 5 different pairs of 2's that cross out, and we're left with just 2 to the 3rd, right? So there's 8 on top and 5 on bottom. After you're done crossing them out, there are 3 on the top. So a variation on this would be looking at 2 to the 5th over 2 to the 8th. Now, there's the sort of the official way to do this, which would be to say it's 2 to the 5 minus 8, right? Well, 2 to the 5 minus 8 is 2 to the negative 3. But we can't have negative exponents. So what we would have to do is take the reciprocal of that, and it's 1 over 2 to the 3rd, which is 1/8. However, there's a different way to think about that, right? So if we go back to thinking about what this actually means, I know, shocking, right? Thinking about the meaning. There's 5 of them on top, and there's 8 of them on bottom, which means that if you were to write them all out and then start crossing them out, we'd have leftover 2's, and we'd have 3 leftover 2's. Where would those leftover 2's be? They'd be on the bottom. So instead of just doing all the official subtraction, you can just sort of say, okay, there's 5 up here, 8 down here. If we subtract, there's 3 extra, and those 3 extra will be on the bottom. So it's just sort of an alternative way to think about that. Going back to our table, the next rule, and this is going to sound a little familiar, is the powers of quotients. Don't worry so much about the names. The rule is so much more important than memorizing the name. Okay, so here we're going to start with a division problem. So perhaps a divided by b. And then we're going to raise the whole quotient, so the whole answer, the whole division, to a power, the m. Okay, so the rule is that it will be a to the m over b to the m. So it's almost like thinking about it as a distribution problem, right? You're sort of, and even though we wouldn't call this distribution, you're sort of distributing that exponent to both the top and the bottom, both the numerator and the denominator. So something like 6/7 to the 2nd would be 6 to the 2nd over 7 to the 2nd, 36/49. Or perhaps x over y to the 5th would be x to the 5th and y to the 5th. So again, we're going to look at why this happens. So we have a over b to the, let's call it third. So what's happening is that this power is raising to the power of 3 exactly what's next to it, which is the whole parentheses. So it's everything inside the parentheses, a over b, times itself 3 times. And because when you do fraction multiplication, you just simply do the numerators times each other, you get a to the third, and you do the denominators times each other, you get b to the third. So that's why it happens. So a few problems that we want to look at that may be combinations of what we already do. So 2x to the third over x to the fourth, and then maybe we'll raise that to the second power. So there's a couple different things that are going on here. First, we have a whole parentheses to a power, and then we also have x's that are in here. And the good news is it doesn't matter which one you tackle first. So I'll show you both ways. Let's tackle the x's inside the parentheses first. So we have 3 of them on the top, and we have 4 of them on the bottom. So I'm just going to simply think about that as an extra one on the bottom. Now the 2 just stays up on top, and then the whole thing is raised to the power of 2. Now we have a fraction inside the parentheses, so it's sort of like distributing. We'll have 2 squared and then x squared. We'll do the actual numbers. We'll have 4 over x squared. So the other way to approach that would be to sort of distribute first. And remember, you have to distribute to everything. So it's going to be 2 squared, x to the third squared, and x to the fourth squared. So now we're going to use our multiplication properties, right? Our powers to powers rules. So we have 2 to the second, which is 4. We have x to the third to the second. Now remember, when we have powers of powers, we're going to multiply those powers. X to the sixth. On the bottom, we have x to the fourth to the second. We're going to multiply those again. We get x to the eighth. Now we can clean this up, right, because we have these x's that need to be taken care of. So we have 8 of them on bottom and 2 of them, or 6 of them on top, which means that we'll have 2 of them on the bottom. We'll get the same answer. Now you may prefer one way over the other. I tend to prefer the first way. I like to try to eliminate more things first so that I have less things to distribute to. You may not have that preference. So here's the practice problems. Just these 3. They are sort of a little bit more complicated as you go along. Stop it, practice them, come back. So here's the first one, right? So we have x squared and y cubed. So they're not like bases. They're not the same base. So we can't actually put them together. So the only thing we can do is take care of this 3 on the outside. So we have x squared to the third. We're going to multiply those powers. X to the sixth. And we have y cubed to the third power. Again, we're going to multiply those exponents because it's a power to a power to the ninth. Next one. We've got a couple things, right? We've got both x's and y's up and down, and we also have this cube. So I'm going to go ahead and get rid of the x's inside and the y's on the inside first. So we'll just write the 2 and the 3 over again. We're not going to change anything there. We have x squared, x to the fourth. That means we have 2 extra x's on the bottom. And then we have y to the fourth and y to the first. I can write that in. So it means we have 3 extra y's up on top. Now this whole thing goes to the third power. Now I'm going to go ahead and sort of distribute this in. Don't forget, it goes to everything on the inside. 2 to the third, y to the third, power to a power, we multiply the exponents. 3 to the third, and x to the squared to the third, which is, again, multiplying the exponents to the sixth. last thing to take care of is simply the numerical exponent. So 2 to the third will be 8, and then 3 to the third will be 27, and there's our answer. Last one. Again, we have the situation where we have multiple x's and multiple y's. So now we have some negative exponents. So what I want to think about here is what happens, right? So we have 5 positive ones on top and 3 negative ones on bottom. The 3 on the bottom are going to move up. Now we already have 5 positive ones on top, and we're moving 3 more up. That means we're going to have 8 of them on top. Here we're moving these 2 down, and there's already 1 down there. So that means we're going to have a total of 3 on the bottom. We have that raised to the second power. We distribute that in. 8 times 2 is 16. 3 times 2 is 6. Nice job.